Hi, everybody. Welcome to our TAC Talk for Tuesday. Today is November 5th, and these are the Technical Advisory Council's TAC Talks hosted by Linux Foundation's AI and Data Foundation. And we have these TAC Talks happening every other Tuesday at 9 a.m. Pacific time. So if you missed any of the previous talks, we have them recorded and they're available to watch for you either on LinkedIn or YouTube channels. And today we always bring technical experts from our technical advisory board at Linux Foundation's AI and Data Foundation. So today I will have amazing guests from Milvus. And Tim Span, he is going to take us through the journey of Milvus, project motivation, background, how to get started. And if you have any questions, please definitely join us on our LinkedIn and YouTube channels. You can always ask your questions live wherever we are in the discussion. Definitely ask them away. We love to see all the great questions, and please don't hesitate to reach out even afterwards if you are watching this recording afterwards. So without further ado, let me introduce Tim Span. Tim Span is a developer advocate at Milvus, and it's such a pleasure to have him join today's TAC Talk. And I am the chair of technical advisory board at Linux Foundation, Vinny Jaiswal. So your host. Hi, Tim. So how
Hey,
about you introduce yourself?
sure. I'm Tim Span. I'm a principal developer advocate at for Milvus, working at Zillas, and my background is in data, AI, streaming, IoT, different things in the open source. And I'm happy to be here today.
Thank you so much, Tim, for making time. Yes, finally we have Milvis covering in our Tech Talks. So super excited. Can you walk us through the journey of like Milvis background, how it came along, and where it is being used now? Yeah.
Sure. I think the interesting thing is what Milvus and vector databases are new, but not as new as people think. This didn't start yesterday. There's some databases just came out, but we are in moving towards Milvus 2.5 very shortly. And there was a big difference between the one version and two as things have evolved in the vector database space. It started off as something, you didn't think you would need this massive amount of infrastructure to run because people were doing small use cases. I had a couple of documents. I wanted to be able to search fast for unstructured data, but people were thinking unstructured data, a couple documents, maybe a corpus of data that was important for one small app. And then as we iterated over time, it quickly became realized that people were going to use this for bigger and bigger applications. And we actually had to redesign from scratch to make things work in a modern cloud native open source ecosystem that can run on different clouds or on anyone's Kubernetes cluster and be flexible enough to scale to what you need, be available as you need, and handle all the different use cases that you may have for unstructured data. And as AI models have improved and as other things in the ecosystem have come about, Milvus 2 has become an interesting unstructured database. And we could show a little bit of the architecture to give you an idea how we went from,
Mhm.
what most people would do when they first design a new data system, starting off with, a single node, maybe a couple nodes. We had a single writer. It was the things you'd think you would do when, you want to have a system that works, but then you realize you need to scale up, need to scale out, and be able to handle tremendous workloads as now enterprises are realizing they're going to have a lot of unstructured data to work with. And, that's just going to get bigger and bigger as time goes out. There's not any way really around that.
Yeah, yeah. And I guess you were mentioning about the changes from 1 to 2 and now to 2.5. It's all happening because of the use case evolution. Like in the last 2 years, there have been a massive shift in the workloads as well. So I guess those demands are being captured in the way the Milvus is progressing as well, I would imagine.
Yeah, and there's been new theories. I mean, when we started off, people wanted to do a similarity search, which is incredibly powerful. Being able to find what you want in text that is what you're looking for and not, I'm just matching some text. I
Mhm.
want type in an apple and I get Apple computer, but I really wanted an apple to eat. Be able to pick up that context correctly is huge. But now we're augmenting that with the ability to do that over images, over audio, video. So I can pack in a little bit of text that says Apple Computer, put in a picture of maybe an old iPod and say, hey, can you tell me about this product? And it can get the semantics from both image and text. So being able to do multimodal similarity search, to be able to do combination of full text and augmented by scalars, so add in extra fields, plus search the vectors, plus support all these different types of indexing styles that have come along using different type of embedding models, whether they're pure open source or you're using the ones from OpenAI and from Cohere and Mistral and some of the other ones. So those are huge. Being able to do recommender systems, that's really big. Obviously, those have to scale pretty big. Doing things like fraud and anomaly detection, that requires a lot of data, support for a lot of different types of data ingest, different language SDKs. It opens up a lot of different things. So I think that's one of the things driving this continuous roadmap.
Got it, got it, got it. So why don't we dive into it, Tim?
Oh, can I share a screen on the roadmap?
Yes, that would be great.
Let's do that real quick. Hopefully, sharing is fast. Okay, so Milvus.io website is very full featured and shows a lot of stuff going on. Now we're almost to 2.5. That's going to be out very shortly, but a lot of the features are already in beta, and some of these are pretty awesome. Like we mentioned, the multi-vector search. This means we don't just have one vector we could search at a time. And when this comes in handy, I've seen this for a lot of people with if they want to have, say you have a store and you want to be able to search things in your store, you don't just have one picture of something. I'll have the front, back, sides. So we could store 10 vectors in one row. So you get back, so if I want to search for, you know, Oreo cookies, I can have all different types of pictures of them, plus extra fields that can give me, text. I can do any kind of integers, a lot of different things around other fields that are in there. And then I could do a hybrid search where I search multiple the vectors, and the vectors don't have to use the same embedding. There's a lot of different styles and sizes. Some that are sparse, and we've added this the ability to work with sparse vectors. Sparse are nice because they take up less space, and they really work good for things where you're closer to traditional keyword search, where maybe I really do want the word apple because it has some meaning in that. So I can have one of those 10 vectors be sparse. and the others be dense and be images, some be text. What's nice is once it's a vector, it doesn't matter. We've added a lot of GPU acceleration, working with NVIDIA and some others. We have added some embedding models pre-put into Milvus. The Python SDK is probably the most widely used, and we also use that to build out the command line interface. It is a very rich library, and it also lets us run our Milvus Lite. Now, traditionally, like I mentioned, we've scaled out the architecture so you can run a distributed database at scale, but not everybody needs to do that, right? If I want to take a notebook and run it against a couple of documents, and this could be 100 documents, I could just do this in Jupyter or in Google Colab without having to run anything else. Just this library will run a local little database file, and I still get all the power of doing hybrid search, multimodal search, and we could show you an example later in a notebook. But that's really awesome. That makes it very easy to get started. Or if that's as big as you need the use case to be, you're set. This can help out a lot of data scientists for processing things to be able to find things right away and combine that for in place RAG is very nice. More things coming, more indexes for some of these scalar types. And these are the fields that sit next to the vector database in the schema so that you have a full database style table. Because you may need, an array of different values associated with whatever your vectors are. We've added indexes for arrays in JSON. So we can have, if you don't know what your schema is going to be, you can create it and say dynamic schema, and we could add fields on the fly. Now, that's not the best for performance, but for some use cases, you might want that. And then once you figure out what something is, then you could define a schema later. In a
Can
in a
can we add in can we add in like ChatGPT feature there if we don't know? Maybe help you brainstorm some of the aspects. How does that work?
on the which?
Like you said, right? You don't know sometimes what features. Can we
Yeah, and
integrate
as you evolve,
ChatGPT there too?
yeah, you keep adding them, and then at some point you say, "Well, this is definitely what I want." Create a new collection, and then we
Mhm.
have tools to migrate data between collections, or you could reload them, or you could do inserts. We also support things like Apache Spark and Apache Kafka and Airbyte and a ton of unstructured ETL tools to move stuff around. We also added a new tool, VTS, that we're improving. This is an open source tool to be able to transfer between different places. And we can bring that up real quick let me get the tools up. There's a lot of tools. You find the tools here real quick. Yeah, see, this is what I was mentioning about the schema.
Mhm.
Like when you're trying to break down something you want to store, sure, yeah, that image, I want it to be a dense vector. I might want the URL, so if I want to get it back, I can get that original image back. Any of the fields, so you really have smart processing of your data. So if I want to do a search, yeah, I want to search a vector of the summary, but I might want to do a keyword search against that too with the sparse, or regex search against the summary text, and limit that to a specific article, an author, different things, and being able to be a little flexible. Like this is defined, but the author is Jason, so I can have different things in there. So that gives you some options. So I thought that was a cool one. Let's get to okay. Here we go. We have the vector transport service, so that'll help me move data between different data sources. Now, usually this is for, I want to migrate into Milvus from some other system, but you could use it to move between Milvuses. Like if I had that old one, I want to move it to a new version or move it to a hosted version. And you could do a bunch of transformations while that's happening. This might be what you want to do when you switch to a static schema coming from that dynamic one. Just a thought there. If you really needed to get off of that schema to improve your performance, you have options.
Got it,
Now
got
we
it.
could,
That's amazing.
yeah, yeah. So one of the cool things we're working on is making it easier in Milvus 3.0, which is pretty awesome. A lot of people's work is data preparation, and there's a ton of toolkits out there, and they're getting better and better. But what would be easy is if I could just take a PDF and insert it into Milvus and have it, store it as a blob and also handle, what vectors it should go into and make that easier so I don't have this step before then. I mean, that's something we're working on. Support for GIS, I think that's an important data type to have. We've had that as, you could do it as text fields or floating points, but to have a well-defined geospatial type is important, I think. So that's
Got
coming.
it, got it. So, Tim, would you mind diving into technical architecture a little bit
Yeah,
deeper
yeah.
too? Yeah,
Let's get.
let's do
We accidentally saw that while we were going through the slides
that.
anyway. So
Yeah,
I think what's interesting about Milvus is it's open source to the core. So we need a couple of serious projects to be able to run in our distributed environment. Now, if you don't know Minio, Minio is an S3 compatible data store. This is where we store our vectors and our indexes. This lets us be stateless. This is a very helpful part of the architecture. Now, what's interesting in a database is our use of either Apache Kafka or Pulsar and our ability to let you pick either one. And this is how we allow you to have, you know, incredibly fast inserts and queries on the same tables while you're doing it. So while I'm ingesting data, it's internally communicated via Kafka or Pulsar. So those messages go in there, and when they get to a point, they're consumed by different things and then made static in the store. But then we'll show you that in the next diagram. But that makes this very easy to scale out and to not overload different pieces of the architecture. Let's just add additional nodes very easily. And of course, when we're talking about running multiple servers, Kubernetes, and we give you all the Helm charts and operators you need to run this, because you'll quickly see you'll have to scale out. And there's multiple types of nodes here. We also collect all the metrics from Milvus and let you build real-time dashboards with Prometheus and Grafana. So that makes that easy to make sure you know what's going on with your system and you don't have to worry about it. And those are key parts of the architecture. So if I'm going to be using Milvus, I'm hitting the SDKs, Python, Java, Node.js, Rust, .NET. There's a ton of them, and there's a ton in the community that are growing. That lets us get in there. Usually, first level is a load balancer, again, to distribute and keep us from getting tied to one particular IP address. And then our access layer has proxies, and these can be multiple nodes that figure out what you want to do. Our coordinator service handles what commands you might want to do. Like you might want to run a query, you might need to insert data, you might need to run an index, and the coordinator uses etcd for metadata storage, and that's where everything is stored there. And then, as I mentioned, in the heart of this, to make this a distributed architecture, is a log broker, and that can be Kafka or Pulsar. When we run on a standalone node, we're just using something like RocksDB because you're not in a distributed architecture. But this lets us add more worker nodes on demand. This lets them consume and process data and do queries and updates at the same time without getting overloaded or slowed down. In the original architecture, there was one writer node, as you can imagine, with all these big vectors coming in that would slow us down. Now things are stored in deltas and updated when they're available. And again, having a message broker allows us to run indexing, data storage, taking data from temporary in the log broker and having it finalized in the data nodes, and having things done in sync without worrying about if something gets lost, it gets retried. So, I mean, this makes for a very flexible architecture. Anyone who's done any large enterprise application knows having something like a log broker makes a lot of sense. And having the separation between queries, data updates, any kind of CRUD work, and indexing separate. So, because sometimes these indexing methods take a long time based on the ones you choose. Indexing of unstructured data in vectors is complex. It could take, a lot of CPU or GPU power, a lot of RAM. Having those in separate nodes work separately. And while you're still able to touch the data, we give you the choice though when you're setting queries, and I could show you that in our GUI tool. You could decide, hey, don't show me data until it's completely finalized. I want to wait till all the writes are done. I want to wait till the indexing is ready to go. Give it to me then. But you could still query everything that's in place now. And then you can adjust that to say, give me whatever you got, as things come in. If it's not indexed yet, that's fine. Give me what's in the snapshots, give me what's local. And it makes for flexibility based what you want. What's nice is it really lets you continue to query. And if you keep querying, that does not slow down my indexing. That does not slow my data finalization from going from the log broker to the object store. And it lets things continue to run. And if I need more query speed, I can add another query node. I don't need to add another indexing node. And you could adjust your infrastructure with Kubernetes to meet what you're doing at the time. I need to do more indexing right now. Very often in, RAG architectures, there's a big upfront load. Like, okay, we're going to upload every bit of old documents we have, you know, all our design documents, all our email, one big batch. And we have a batch writer that lets you do these in bulk, and it does it very quickly as opposed to doing, little insert with Python. We've got a batch API so you can push that in. Or if you're, someone who uses Kafka or Pulsar, we have a Kafka Connect that'll push into Milvus that way, depending on how you want to load your data. But traditionally, that big batch push, that happens in the beginning. Maybe I want to up my data nodes and up my indexing nodes while that's happening, but I could still query it as it's coming in. And, whenever a segment gets full and it gets written, finalized, then that'll be in the next query. But if you're doing a big load, you might want to wait, but you might want to see how far along you are. And for some things, hey, it's okay. I got the stuff from the last minute while the other stuff is still loading. You have a lot of options here. And obviously, if you throw more RAM, nodes, CPU at things, GPU, things can be tremendously faster. We've seen with the new NVIDIA GPUs that we can get much faster loading and running of indexes for even really large workloads. Things that might have taken a day can be done in minutes. So, however your
And
budget and needs are.
yeah, and Tim, what does the processing look like for the video files, for example? Does it support the video files?
Yeah, what's nice is that does not affect Milvus. So what
Mm.
happens is you'll pick a right embedding model that does video, and there's not as many video embedding models as some of the other ones. We could actually show you real quick here. You want to see like the different models, and we could show you some of the main embedding models and what type they're doing, and you can pick them. Now, there's also what happens with this is there is a company 12 Data that has a really good video one. So we work with them. If you go to integrations and go to 12, they do some really amazing stuff. So we use their models to turn video data into that. Let me show
Okay.
you what makes this interesting is there's other than connecting to them to use their model, it's the same code that we'd use for video, for text, or anything else. We run their model, and then we just do an insert. And we have a
Yeah.
couple fields here, pretty easy. Now, the horsepower, to break apart the video, they're bigger files.
Mhm.
It takes a little longer than doing, 100 things of text, but you don't have to change. I mean, it's a regular insert. It's a if I showed you this code for something else, you wouldn't notice the difference. You're like, okay, it's got a couple of fields. What might give it away is, it says video URL, and it has an offset for each part that is putting in there. But other than that, it's the same way we do that for images, text, audio. You just have to get a model that does what you want it to do. There's not there's no, oh, I gotta write something new or change the database. It's just a different type of vector, and we support any of these embedding models, and a huge amount of variation on how many dimensions there are on each vector, and a lots of different options on indexing, which we didn't really go over yet because that's a big kettle of fish going over. If we look at all the different options in indexing, there is a lot because we designed it to be flexible because these
Yeah.
things change and you might want different things. Like flat gives me exact match. Now, usually when you're working with unstructured data, you're like, I want a percentage, maybe 80%, 85. But you say, Tim, I need exact match. If I have this image, it's got to match. Maybe this is an ID system. I can do flat. Now, flat is not the fastest. But if I have 1,000 people with IDs, maybe that's okay. Now, then we added inverted one. This is faster, not as accurate, but you get the little trade-offs, and this scales more. And then you say, hey, I have so much data, I want to squeeze it down so we could quantize the numbers, make it even smaller. If I've got a GPU, the GPU indexing really fast. Or if you say, hey, this text, you know it's mostly keywords, or I know what this corpus looks like. It's very fixed. A sparse index can be really small, really fast. And if I can still take one version of the data in a sparse, one in, say, IVF flat, and now have millions of text files I can get to really easily, which is nice. So again, this does make it complex because you have a lot of options. So, I mean, depending on, what your data looks like, how you want to do it. There's a lot of trade offs in indexing, but that's like everything else. Your mileage varies based on your use case, based on your availability of GPUs, storage, how fast you want it, lots of stuff there.
Yeah, and that's awesome, Tim. Now I want to dive into some of the really powerful use cases that Milvus is driving, like, real production use cases.
Yeah, I mean, these use cases we mentioned, let's bring them up again. Obviously, retrieval augmented generation is huge for everybody,
Hmm.
but now let's get down here. These are big ones, and these are all in production. That's why we mention them. And if you saw some of the people on the next screen, wow, let's get over there. That's what they're using in production. And I can tell you, basic similarity search is a big one, and so
Hmm.
is augmenting your retrieval augmented generation because you know being able to reduce hallucinations. I think we actually have that. Being able to get just what you want from your knowledge base and give that to the model to give you reliable answers is huge. And this use case is very prevalent and it just keeps getting better as you can add hybrid search to this. You could use graph representation. There's a lot of ways to enhance this. The new agent frameworks are making this better. And again, being able to take what you question and get it just on what you need, reduce hallucination, reduce cost. And you also find out I can cache some of this, and we have a caching thing. Or sometimes when you hit the semantic search, the results are so good, you're like, that might be what I was looking for. I don't even need to go to that next level. But RAG is huge. Semantic search by itself, just being able to search unstructured documents, unstructured audio, video, whatever you have, really big. Uh, there are some pharmaceuticals and chemical companies that are using this for doing searches against molecules and chemical assets. And there's some people have created interfaces where they can, adjust a molecule and use that to query. Again, because anything that can be vectorized can be used to search and to be stored. So you can find things that, would be really difficult to do that search otherwise. So those are some of the big ones. Again, you could probably have a business just doing RAG. I know a couple of companies doing that because being making models more accurate, cheaper to use, less hallucination, and keep them to your data. And with the open source models, you could keep run this all internally. Keep this in, your own cloud or on premise with, Milvus hosted wherever you want to host it and run a local model. There's a ton of those. IBM Granite, there's some from Meta. There's a ton of open source models that do really well. And you can run them even on your laptop with things like Olama and VLLM. So it makes it really easy to make these use cases. So that's why those types are the ones going into production first. And I think we'll see at some point. I can't see why everyone's not going to have RAG, especially agentic RAG, where you can have things as part of real world applications. Find me the best way to get to work, and have it do the function calls, have it do REST lookups, have it hit different things in the vector database, make a couple of LLM calls, maybe call some small models and come back with the results. And then you interact with it and say, hey, give me another option or give me a cheaper option. Or, yeah, it's cheapest to walk, but I don't want to walk 7 miles in the rain. Let me get on the subway or something different. You know, those things are huge. And I think those will get bigger and better as being able to process this data is getting better. Like, say, legal. We have a partner in the open source, Unstract, that makes it so you can grab things out of documents, even really complex ones. I mean, there's unstructured data, but if you have a very structured document, it can be really hard to get that information out. Embedded charts, embedded graphs, tables, pictures. With the right models, you can pull out, any of that information with pretty good accuracy, and it's getting better. Once you could scan any kind of document and make it available for instant query, or a full cycle of asking questions as part of advanced RAG, that could seed a lot of production applications. And I know that's starting in a couple of legal places now. Do they have it in
Yes.
production? It's possible. Some of these things they don't want to
Yes.
tell people right away.
Yeah, that's true. That's true. Yeah, I see that there are a lot of like cyber threat
Oh,
detection and
security.
social media
Security is a big
companies.
one.
Yeah, yeah, yeah. Social media companies, they always have to look into that processing as well. So it's a huge use case if
Well,
we
think
can
about it
allow.
for banking.
Hmm.
I can have the picture. Is that really the person who does that? Is this ID
Hmm.
right? You know, and be able to check those things, be able to other check things online at the same time, and feed in something from someone's in the bank's app asking, hey, it seems like my account's less money, and you could search that and say, oh, they're at home, someone's at the ATM, do you have someone else? And you could interact with them, whether that's augmenting people or having an actual chatbot say, hey, are you in you know Pittsburgh, Pennsylvania right now, taking money out of your account with an ATM card? And you could say immediately, no, that's not me. And these things can go back and forth and interact with other systems. This could be a really good agent for them. I know those are use cases that make sense for them, to be able to track transactions, chat that you're having with the user, things happening in email, things happening in pictures. So you could go, is that you? Hey, if that's you, wave at me. We could say, okay, that's you. You're fine. Don't worry about it. We know it's you. Okay. Those sort of things.
Yep, yep. Cool. Tim, there are a few more minutes left. Why don't we give community some resources if they want to, find you afterwards, like to contribute or like, yeah.
Oh, yeah. Yeah. I mean, as always, everything's open source. Go to GitHub, start looking at it. Give us a star, is awesome. But if you have issues or questions, you could come here. We also have a really great set of community links here. Definitely come to our community page. Our Discord is really active community. We have people and AI helping them together using RAG. So that's our real world use case. We use our own stuff. It lets you ask any question, and there's no bad questions. If you need help, there's people there to help you, and maybe AI powered people, but we're there for you. We're also on Reddit, and it's there's detailed things going back and forth where you'll get your initial result from the RAG, and then one of our engineers will chime in, someone from our community will chime in, another user, and it's a great lively community. And then when you're ready, anything is a contribution. Looking at a bug, putting in an issue, go, hey, I think it should work this way, or suggestions. Those are all valuable. Fixing a typo, that saves someone else from doing it. We love to have anyone help out. We do meetups all over the United States. I'm here in New York, and these are recorded to YouTube. We also usually stream them live, depending on where it is. But usually we're able to stream them live, and we've got events coming. Many times this month. in Berlin. We also have some in Asia as well. And I'm personally speaking at the AI Alliance in, oh, that's tomorrow. That's real soon. And we'll talk about Milvus and some of the other things in the AI Alliance. But yeah, there's a lot of ways to connect with us. Please reach out. We're always looking for new people. Even if you just want to try out a notebook and do a search and find cats, that is not a bad use case. Get your cats out of the database.
Yeah, always, always.
You got to have
And
cats in
Tim,
your database. It's the internet.
exactly. Yeah, exactly. Um, and Tim, since this is a graduate project with Linux Foundation's AI, with
Oh,
our
nice.
foundation, can you talk a little bit about, why you chose this foundation, or like any thoughts around that? Yeah.
Yeah, I think the Linux Foundation is very helpful because of the open community, and we get to work with other people in there, like VLLM, uh, like people in the Kubernetes space. It's if you don't have a community, you can't build on open source. You can't do it yourself. And Linux Foundation, especially data and AI, has got the best voices and people looking to collaborate between different things. And being a vector database, it makes it very easy for us to work with anyone in the ML space, anyone in data. So yeah, I think it's my favorite group to work with. There's so much good in there. If projects aren't sure where to go, it's a no brainer. If you do AI
Yeah,
or
and
data, join us. We love it.
mhm. Yeah, and Midwest has integrations with other LFA and data projects, so it's good to see the, amicable relationships between different projects. They are bringing integrations and keeping the data and AI space moving forward, I guess.
Yeah,
Awesome.
proud
Any
members here.
Yeah, so definitely, Tim, I think you already shared a lot of resources. Anything else that you would like to share that we haven't covered for Milvus, or
I
any
didn't show
listener?
you this tool. This is an
Mhm.
open source tool to look at your data, do your vector searches, and it's a great way to find out what you're doing. There's also some cool new features we put in there so you could explore data, even if you got a ton of it, how it connects to each other, whatever that data is. For me, I've got live planes. It shows you how your data is partitioned, what segments are there for storage, what your data is that you could go through. And again, remember that different consistencies. You could see what it looks like, all the fields, add indexes if they're not there yet, and then they'll build for you. And again, this new feature we added is the ability to explore data. Also, will give you pre-generated code for Python or Node.js. So if you want to do a query, you can just come here, copy it, put it in your notebook, and you're ready to go. So this is a nice little UI we have here, and it'll let you pick, the fields in there. It lets you do things like just do a quick filter on things. Any of the fields in there, I could do. I could do any kind of equal and then. Again, this is a nice tool. Definitely check that one out. It's ATTU. Atu or GUI. That's the main one.
That's awesome. And Tim, is that like a part of Milvus, or that's a separate tool you built?
It is a separate tool you don't have to run. I mean, all of
Mhm.
this can be done command line, REST endpoints, but this is an open source project for Milvus that that we collaborate with, and it's Apache licensed. It is available to anyone to use, and it's good for you looking at what's under the covers, seeing what's going on with your system, query, do admin stuff, and not have to do command line.
Yeah, definitely. You
Command
can have
lines,
visuals on what.
yeah, it helps. It helps to be able to see what's going on in your system.
Yeah, yeah, yeah. Awesome. This is very cool. I'll check it out as well, Tim. Yeah, I think we are almost at time.
Oh,
Anything
it's
else
pretty close.
that we didn't get to cover, Tim?
I mean, there's a thousand things, but you know,
Thousand things we can talk about, but yeah, in this short amount of time, I think you got everything. We got technical architecture, we got the deep dive into the code, the UI that you can check out, the use cases, and then don't miss out tomorrow's talk that Tim is gonna present. So it's happening in
they're good
NY.
speakers. Eh?
Yeah.
Very cool.
So yeah, definitely check it out. And thank you all for joining, whoever is live. If you have questions later on, please definitely ping them on our LinkedIn and YouTube channels. And you can always find Milvus on GitHub and milvus.io. So please check them out if you are curious about any other projects too. We host them in LFAI and data um, wiki, and we have websites. So please check out information there too. Again, we will be doing Tech Talk in 2 weeks. It will be with Delta Lake, and don't miss out. If you want to check out any previous talks, definitely, yeah, stay tuned with us. So
Very
thank you
cool.
all. Yeah,
Thank you.
thank you, Tim.
Thank you.